Welcome to our online demonstration of OptOSS AI. In this product walkthrough, we'll dive into the functionalities within the OptOSS AI product that uncover actionable insights from raw data and grant network operators truly superhuman monitoring abilities. Once OptOSS AI is connected to a network, which for the purposes of this video consists of the OpNet lab environment, we are able to log in through the GUI and the Launchpad view is presented. The Launchpad consists of two primary sections, namely the menu bar along the top and the main window below. The menu bar is divided into three subsections, each containing one or more functional buttons that open up new windows. These include the customizable dashboard, the anomaly analysis tool, and the asset overview functionalities tool. Additionally, the user and server login information is displayed in the top right corner. The main window in the Launchpad can be customized to display a variety of useful information in the form of widgets. The most basic widget is the clock, which displays the client's time and highlights any potential differences versus the user's local time. Next, the Online Overview widget indicates a number of statistics pertaining to the total number of events and anomalies in OptOSS AI's current active memory. The first number summarizes the total number of asynchronous data points, such as syslog, SNMP traps, NetFlow records, and other such events, which have been dynamically streamed to the OptOSS AI instance. And the second number highlights the total number of synchronous sensor data points, such as SNMP gauges or counters. The following numbers indicate the number of detected anomalies and anomaly clusters in the data streams. We can see there has been a reduction of 5 orders of magnitude, from 10 million events to 600 anomaly clusters, which represent the repeating anomalous sequences detected within the log data. Similar statistics are also visible for offline or archived records. Finally, the last widget consists of a list of all current active processes, which can be individually expanded for further insight. It's worth noting that this Launchpad view is entirely customizable on a per-user basis. For example, the widgets can be resized or closed, and custom widgets can always be integrated as needed. Now, from the Launchpad, we can go through each of the functional buttons along the top menu bar to understand how OptOSS AI delivers on its promise of making operators superhuman. Clicking on the Dashboard button on the menu bar opens up a new window which provides a global overview of the monitored network. This view is again completely customizable and users can save different views as needed. In this demonstration configuration, the main dashboard features a few key widget elements. The Sun widget provides a 360-degree view over the entire network to the operator, using a number of concentric rings to graphically visualize the status of elements in the network. The arrangement of the rings is configurable per the specific needs of the operator and can be customized based on parameters such as vendor, department, up-down status, and much more. The lines that extend from the edge of the sun provide a visual indication of where the events are taking place. The orange graphic visualizes raw asynchronous events coming in, such as syslog lines and SNMP traps. The green graphic illustrates the sensor data streaming in, which are synchronously pulled. The blue charts visualize the AI's processing of all the events and sensor data. The red chart indicates anomalies as they are being discovered in real time by the AI. These are then summarized in a histogram view below. The histogram allows you to see which anomalous patterns are occurring most frequently, and clusters can be recolored once examined based on risk to help prioritize any remedial actions. Under the Assets tab, operators can maintain oversight of the network inventory and topology. As a bit of background, OptOSS AI is able to automatically create precise audit reports and maps, and quickly and efficiently collect the most complete information about the managed network's inventory, topology, and map of IP addresses. Whenever network elements are configured or a new device is added, infrastructure update cycles are triggered. The element inventory data is automatically retrieved by OptOSS AI as soon as it receives notification that any infrastructure has changed. All network devices can be configured to send syslog and SNMP messages to the OptOSS AI platform via UDP or TCP network protocols. OptOSS AI receives, processes, and profiles this streaming telemetry in near real time, and by understanding the topology of the network and continuously monitoring activity, users can use OptOSS AI to easily find redundant devices, identify devices for decommissioning, misconfigurations, and more. But let's dive into some of the functionalities and see what OptOSS AI is capable of. By clicking on the Devices button, we are presented with a view of all of the devices that are being managed and monitored, providing insights on vendor, type, status, location, and any custom tags. With hierarchical sorting capabilities, even a network of thousands of devices can be easily summarized and categorized. In this example, we have summarized the managed network by status and device vendor, providing a straightforward view that is easy to navigate. Since we have all of the information on devices, it makes sense that OptOSS AI can also provide a complete inventory of these devices in terms of hardware and software, which can be accessed by clicking the Inventory button from the Launchpad. Software types, hardware types, line cards, serial numbers, versions, releases, anything you would like to know about your equipment and inventory records is covered in this window. By collecting this information, OptOSS AI is also able to dynamically attribute the impact of ongoing anomalies and link them to your inventory records. Next, the Map button opens up a window which presents a diagram of your managed network, as per your most recent configuration change. OptOSS AI currently supports multiple routing protocols, including OSPF, ISIS, PGP, with several more under development. The map displays IP connectivity with more views that can be tailored as per the user's specific needs. Finally, the IP addresses button provides the full overview of all connected devices. Now that we've covered the basic functionalities, we can move on to the real magic. OptOSS AI applies its patented process to detect, cluster, label, and recognize both known and unknown anomalies on a network. Combining anomaly detection with real-time visualizations helps operators to more intuitively detect dangerous developments on the network and massively reduces the mean time to resolution for the root causes of critical incidents. In this instance, we'll first enter the CT scan view. In the form of a streaming or historical alarm watch view, coupled with the deep diving capabilities of the anomaly cluster view. The interactive CT scan visualization illustrates the extent of different types of detected anomalous activity across a network over time, with color codes highlighting levels of severity, clearly visualizing and communicating any hidden patterns to operators. In this view, the red axis denotes time, the dark blue axis captures the different devices, and the vertical green axis corresponds to the severity of anomalies taking place. This cuts through the truly chaotic world of a large network, capturing the activity of millions of actors, depicting small incidents, scheduled activities, large outages, and even subtle hacking attempts. Invisible stochastic noise can become a powerful symphony of insightful findings with this multi-dimensional view. The CT scan can be sorted and segmented across different timescales, devices, anomaly types, and more, depending on the scope of analysis being considered. Now, let's take a look at the alarm watch view. When incidents are detected and brought to the operator's attention, the point-and-click interface on the streaming alarm view provides operators with the ability to zoom in on the full context of any anomalous activity and allows for rapid root cause analysis and remediation when necessary. As such, the user is provided with a real-time overview of anomalies as they crop up. In essence, the CT scan view, highlighted before, is actually a summary of thousands of these individual views. The granularity of the overview can be tuned in terms of refresh rate from seconds to minutes to days. And multiple devices can also be viewed at once for real-time cross-correlation. The Alarm History button opens a window that provides a historical overview of anomalies that have been detected. This view allows operators to perform rigorous post hoc analysis, cross-correlating across user-selected devices and isolating the root cause of incidents with ease. For a selected time period, the user can zoom in for more granularity or open up another view for further detailed analysis. Finally, the Anomaly Clusters view presents the findings of the AI engine, where clusters represent groups of related anomalies. Clusters allow us to turn an alarm storm into actionable intelligence by condensing the oceans of data into a manageable number of clusters. Here we can see the anomalous activity of a network with millions of data points per day, represented by the 10 most frequently occurring anomaly clusters. All subsequent automation, data mining happens on a per cluster basis. OptOSS AI brings you to an automated network one cluster at a time. Clusters can be sorted by frequency of occurrence, by when they started or ended, by vendor type, and more. Various widgets allow users to interact and study the clusters. The AI engine collects similar groups of events into similar clusters so that the user can dive deep into each anomaly cluster to analyze their causes and sources, and proceed to fix them one by one based on the results of the analysis. A chart is also available so anomaly clusters can be visualized relative to their origin. The pink circle tells us all of the anomalies are syslog data. The green circles group our Linux versus Juniper devices. Users can quickly study where the most of the anomalies are originating from and can set up the hierarchical tiers as they wish. The Sankey chart tab is for data scientists. It visualizes the links between anomalies and shows how various sequences of anomalies result in clusters. The Sankey chart provides insight into how one anomaly is related to another so that the interdependencies can be explored. Most importantly, OptOSS AI allows users to automate workflows and actions in response to discovered clusters. The system automatically gives names to the clusters, but these can be edited. Labels and actions can be added to the clusters to assign priority and create alerts or tickets. The most powerful tool here is the script feature. This allows us to add a script that is automatically triggered if the anomaly cluster ever occurs again in the future. This could be an automatic remediation script to reboot a server, or a data mining script to collect information on the affected users, or an API script to create a ticket for your level 1 engineers to examine a device. It could even be a script to feed a custom widget to visualize a problem for your operators. The possibilities are endless, and this allows you to move to a fully automated network one cluster at a time.